Good morning. Well, we'll go ahead and kick it off. I don't have a whole ton of content. I'm very heads down on a challenging project at the moment. But I do want to talk a little bit about some issues that are have cropped up recently. With some contracts as Soroban's been taking off a little bit more. We've had some engagement on a couple of these contracts higher than we normally have, which has popped up a couple of design issues that I've noticed with storage and how people think about it in between simulation and submission. A lot of it's maybe theoretical, but I could maybe pull down an example and kind of talk about it. Before I do that, just because it's fun, I have been doing, I'm going to be honest, I have been doing a little bit more work with the proof of teamwork asset, Kale. So let me share my screen. I'm going to keep hammering on this until Elliot, you're in here farming kale with us. I know, but this is my next strategy to get you guys involved here. So we've got our Kale asset, which now has lore. So that's step number one. Bree wrote us some lore. So as a backstory, but it's this proof of teamwork asset that you can mine on Soroban. It's quite fun. An interesting balance between hash power, timing things, and staking. So kind of a unique asset here. You're not just trying to mine with a GPU, but you've got a couple of different items to play around with that all contribute to your final share every time a block closes. But anyway, this is tiny. All of that to say, I've been working on the next iteration of a project where I'm essentially trying to I want to be able to mine Kale in the browser, but that is very hard to do because browsers are not multi-threaded, and to be able to hash anything at sufficient speed. So basically with hashes, you're trying to get a prefix of zeros at the beginning, and the more zeros you get, the more a word you get. But because there are 16 different characters, one of these could be, every additional zero increases the difficulty of finding a hash by a factor of 16. It's like a 7 or an 8 is pretty tricky, which is why multi-threading becomes so important, where you're not just using one of your cores, CPU cores, to run the miner, but you're spreading the work across all of your cores. Browsers are notoriously bad at doing that. So there is this concept of web workers, which makes it possible to use multi-core. But then the other problem is generating the actual hashes. So taking a block of data and then converting it into a hash is also a bit intensive for like JavaScript to do, which is why the miners that have been written so far are a C++ miner. If we scroll down there, Fred's written us a C++ miner, and then I have a Rust miner. There's not a JavaScript miner because it just doesn't generate those hashes very quickly. But browsers don't run Rust. But yes, they do if you use WebAssembly. So essentially what I'm trying to do is build a Rust WebAssembly file that can be loaded up into a web worker that can produce hashes at high rates of speed using that, because you're using multiple workers, you're using multiple threads. And I just got it to work. So a difficulty of 7 is pretty difficult for a browser to run, and I can return it in not too long. It's about 8 seconds to get a difficulty of 7. So that's pretty fire. There's lots of work that needs to go into actually turning it into an interface, but the idea being combine launch tube and pass keys and browser-based mining and we should be able to build ourselves a little mining website where anybody can very easily jump in and mine some Kale. And maybe we'll get a converted version of this for FCM. But I'm getting to learn all kinds of things about how to use WebAssembly and how to do multi-threading in Rust. Quite a lot of fun. I use, not on the browser, no, Bun does not, you can compile it, I guess, but it's a bit difficult to use Bun right now in the browser. There's some things you can do to put it on the back end to then generate a front end, but it's definitely not going to be nearly as fast as using Rust. Bun can load up WebAssembly files, and I'm actually doing that. If you look at my Rust miner, it uses Bun to do the farming and the working. So this one's actually spinning up different workers to do that. So I actually am using Bun for this one, but that's a server-side application, not a client-side one. Zig would be awesome as well. I would love for someone to do that. I think TDEP had worked a little bit on like a Soroban version of this, but it would be cool if somebody, so there's plenty of space here. I don't know if you saw, there's plenty of space here for someone else to write a Python miner. I would love to see a Zig miner, assembly script. What was that one, the Cobalt that all the older folks are using? Plenty of space for people to create different miners. But I'm using Rust and then Bun, and then I'm gonna try and build this web-based one, which would be really, really cool. But that's not what we're talking about today. What we're talking about, I'm gonna drop a link to that really quick though. What we're gonna talk about is this issue that's cropping up around storage and simulation submission. That's caught a couple of folks off guard. It's like one of those things where it's really obvious once you see it, but by the time you've seen it, it's typically too late because your contract is then broken. Let me start a new project here, and I'm going to be honest, I have no idea what the state of my CLI is because I'm in between like protocol 21 and protocol 22 right now, so I don't actually know if any of these commands will work, but let's get this opened up. I'm not sure what examples or what version our examples are running in these days. Ooh, 21.0.0. Let's run in, I don't know if I'll actually execute this on testnet. Let me go ahead and pull in. So, fun fact, if you ever need to pull in like a new beta version of something, you can always just go look at the docs for the Rust SDK and then click on the version and copy it. It doesn't show up. I wish this thing would show like beta versions of things, but it doesn't do that. So I'm going to put in the protocol 22 because if we upload this to testnet, we'll need to make sure it's using the right SDK. So basically what's going on, this is going to take a minute for it to get all my cargo stuff with the next version, but that was actually pretty fast. If we're storing something, really anything, but particularly like persistent entries or instance entries that are technically persistent, you've got some key, and then your value is what's happening is there's like a value of vectors that is like unbounded or unconstrained or variable. So you're storing some vector of data that as it's invoked could change. So we all maybe are aware you definitely don't want to set your key to be something that's variable. Because if your key is variable, simulation and submission will definitely be different. Like let's say you used the RNG generator for your key values and you've seeded it with the ledger number. Well, in your footprint is going to need to read the key values in order to know what values you're actually touching. And simulation will run and produce some RNG to produce some key, and then submission will run and it will be a different key. And so your footprint will be like, hey, or Soroban, I guess, will be like, hey, you're trying to access a key that does not exist. And that definitely has thrown me for a loop. A lot of the a few of the RP Siege quests, challenges. And I feel like I say all of this stuff and realize that there may be some people who have no idea what I'm talking about. But I have done a lot of coding games in the past, and around Soroban and Stellar, which is where I've learned a lot of the things that I talk about. In a couple of these RP Sieges, it involved a broken contract that you had to fix, or writing a contract that hits this particular issue where your key name will be different between simulation and submission, or you can't use simulation because you're trying to find a value that is static. And so you can use RNG as a key, but you've got this unique issue or situation in Soroban where you have the ability to run a simulation which will produce the footprint for you when you're submitting a transaction. And the hope is that it produces the right footprint. But that's not guaranteed, particularly in cases where you're using RNG for something, or even if it's not RNG, but there's some variability in the case that I most often run into. I have a key name for something, like I may be seeding some value with the ledger number or timestamp, and that value is going to change between simulation and submission. And so the value is going to be different, so the footprint won't match. That's certainly one issue. And so the way that you often will get around it is put the variability in the actual value. So the RNG piece goes in the value, and then the value gets stored, and then it can get read back sometime in the future, because the values are not in the footprint. Only the keys are, which can be really helpful if you have custom data that you want to add that you don't know at submission time, and you need to use simulation in order to get it. The nice thing is simulation is only going to read the key values. So the key value stays the same, and then the value can change. Well, there's another problem that's basically the exact same issue with the values, in that if your value being read is changing, the footprint's going to yell at you again. But it's going to yell at you for different stuff. And it really depends on the contents of your contract and what's actually happening and the level of variability. The one that I have seen popping up right now is that your bytes read value is incorrect, because if, let's say, you've got a vector of data A, B, and C, and let's say A, B, and C are all, addresses or something, so 32 bytes, you're going to be reading that 32 times 3. In simulation. So simulation is going to say, okay, cool. When we simulated this based off of the data that was on chain, there were 3 values. It was 3 times 32. And so that's going to be the number of bytes that you're going to be reading that will then get put into the footprint, so that you're paying for those bytes that are then going to be read. But if between simulation and actual submission, another value gets added to this array, you're just going to yell at you that you said you were going to read 3 times 32, but what we found in actuality when we read back the value and then tried to use it, there were 4 values here. And so you're not paying for enough bytes to do that many reads, which you can either solve by A, not using simulation, or if you know that it can only be variable up to a certain number of bytes, you can increase by that threshold and just pay for it. And you may not need to pay for it, so you may be overpaying for those 32 bytes, but at least you won't underpay. So the transaction won't fail. You just might pay more than you would need to, because you can pay over those number of bytes, and it will be fine. Set your read bytes 32 bytes over, or whatever it might be. Addresses are not 32 bytes. They're, because it's XDR, there's like some header information. So for what it's worth, it's more than 32. You could figure out exactly what each additional value being added to this data that you're storing, what that actually adds, and then add that to your read bytes, and then also make sure you pay for that additional read, so that you don't run into this issue of, when I simulated, it was 3 values, but when I actually submit, it's 4 values. And this happens, one of the reasons that this is cropping up now is when the blockchain's like underutilized, in that there's really only like one person calling the contract at a time. It's this sequential series of events where I add, and then I call something that uses what I just added. And so there's no risk of something being added and being read in the same ledger. But as the blockchain gets used more and there are multiple requests going to this contract at a time, you're going to have a read request at the same time that there's a write request. And so they get ordered, but simulation looks at the existing state of the database of the ledger, reads, oh, there's only 3. So it builds your footprint off of 3, but then in between when it read and when it actually submits, an additional item has been added. So you've got to build your contracts with this concept in mind. And again, it's one of those things where it's like, yeah, that actually makes a ton of sense. But unfortunately, it's too late, and now my contract's maybe not bricked, but it's really hard to rely on simulation at this point, because the contract could be pulling data that isn't, or it could be simulating under what the contract is actually going to end up needing. So again, there's ways around it. If you can update your contract to not do this, that's a great idea, and I can talk about some ways to get around that. But your contract's not necessarily useless. You can suggest to everybody to overbid their bytes and their budget. Again, depending on the contract, that may be really hard to do, because if this is like legitimately unbound, and an invocation technically could add hundreds of values to this vector, you would potentially have to overbid this by a tremendous amount, which is not ideal, which is one of the reasons you don't want to build in this way of vectors that who knows how big or small they are at the time of in between simulation and submission. And that's another thing to keep in mind as you're developing contracts, is this idea that, like, what happens when a lot of people are calling this? The problem with testing right now is you're not going to catch this issue in testing, because you tend to write tests, or you can only write tests without this idea of simulation, where you're not pulling live data from the blockchain, and then between when you pulled it and when you actually submit against it, that underlying data has changed in some way. But that's the live network. That's the way the network actually works, which is, again, it makes a lot of sense, but it's not necessarily obvious during testing. This kind of stuff won't come up. Like, I ran into this issue with key names, where my RNG was fine because I don't have a simulation environment in my testing. And so every test was working fine. But then when I went to the network and started doing simulation submit, everything was breaking. This is kind of the same situation that's going on, where everything, of course, is going to work in a test just fine because you're doing everything serially as one user, versus this dynamic environment where many people are reading and writing to the database, to the ledger, all at the same time. So you've got to design your contracts with that in mind, that what happens if we become really popular and everybody wants to read and write all at the same time. Some ways to get around that. I mean, the only way to really get around that is to not store dynamic vectors. Don't store things that grow indefinitely. And most of the places that I've seen this, it's unnecessary. It doesn't need to be stored that way. There are some, there's actually an interesting example with the color glyph app that I'm building, where I do have a vector that grows. It's not indefinite, or it's not unbound, but it is pretty large, and it gets filled up slowly over many transaction submissions. But it's per asset, and only one user can call it at a time. It's like baked into the DNA of the function that when you start writing a glyph, only the author of the glyph is allowed to continue to increase its size or write to it and kind of progressively mine or mint a glyph with additional color values. And so it's baked into the logic that even though there is a value that's a vector that's growing unbound, or not unbound, but growing dynamically, that user is the only one who can call it. So a simulation pull and a submission, nothing's going to change in between those two things because it's owned by, in that case, the author, the miner, the artist maybe. In these cases that I have seen on the blockchain, it's not an owned vector. It's kind of just a system or contract vector that's like trying to coordinate timing or coordinate a certain state in between, like a deposit and withdraw, or some timing event, and we're not actually sure how many people are involved here or what the status is. You really don't want to end up in that type of situation where these vectors, like, you don't know what the size of them is. So one way to get around that is by having, again, it really depends on the type of contract that you've got. But if you can, store things in some way where the part of the key name is like the address. So you would have like a custom type, and I'm gonna not write a custom type, but basically something that would be very similar to a custom type, where you've got something like a user address and then some ID of like a timestamp or something. That would be the key name, and then the value would be, I don't know, whatever the value that you're trying to store is. And then you've got a key name that's static, and then the value that's variable, but at least it's always pinned where I've got a single static value, and then the dynamic portion of it comes from the key. So there's some ownership or authorship piece of this. That's one way to do it, where you're separating, and like instead of having a vector that's unbound, you essentially have you're using storage as like a map, and you've got your keys and your values, and whenever you need to go back and read keys, you can reconstruct a key once you have a user and an ID. So a user could be something like when a withdraw request is coming in, the user is making that withdrawal, and so you can fill in that piece there. And if you know the ID, because maybe this is like a sequence or a ledger number or something, if you know what the ledger number is, you can fill that one in and then collect a bunch of values from that. That's one way. That's probably one of the more typical ways of don't use a single key to store a large array of values. Use storage itself as the array, if you will, and then fill your array with keys and values where there's some type of common key, which is usually where that custom type storage key or storage item or something like that. And then you've got a variability item here, which allows you to customize what that key actually is, and then the value. So you know I'm going to be having a lot of different storage items whose keys will be variable based off of the user and the ledger. So something that is known or static comes from an argument, something we can look up, and then the value is the only piece that'll be custom. So that's one way of doing it. Another way of doing it that's actually kind of interesting is using pagination, which is something I was spent a bit of time, but it actually ends up being pretty simple, where you store some value, probably in like instant storage. Instance, this is all pseudo code for what it's worth, but you get the idea. And then you would be like max page or something like that. So you would store a max page key and then a max page value, which would be the U32 or something like that. And then you're going to store some sane bound set of vectors, some sane vector range. So then you would say something like the current page value. I'm sorry, current page value. So this would be like the iteration, page 0, page 1, page 2, page 3. And then you're storing a vector that is not unbounded. So you are absolutely sure like let's say this is a page, and this page is always going to be, is always going to be 20 items long or something like that. And so even if it's not completely full, you're absolutely sure it's never going to be more than or less than 20. And then your values could be something like an optional address of some sort. Maybe you're storing an address. I don't know what you're storing. But then all of your values, like you would pre-fill this page with a bunch of nuns, right? 20 of them. And then whenever you need to fill your vector, you could look through and find all of these values whenever you need to call it. So you know what so essentially you'd be storing the page. And whenever you need to add a new item, you could say like, okay, how long is this page? And you don't even necessarily need to store 20. I guess you could store less than that. And then if it was less than 20, you know that it hadn't hit the max yet. The idea being there's some static max length page for this particular item. And then every time you hit the max and need to go to the next page, you increase your max page key to whatever the current page value is plus 1. And then you know that, okay, if I've got 6 pages, I've got to go inverse. I've got to loop over 6 pages of these values and then pull out page 0, page 1, page 2, page 3, page 4 to get all of those vectors. But it's not going to be this scenario where the value is constantly changing, growing and shrinking. So that could be another way that you could potentially get around this issue of dynamic vectors. I haven't experimented too much with doing this, and I'm still not convinced that storing anything in a vector that could probably be this way of doing things, where you just have storage items being the keys and then storing those values. I'm just not convinced that that's the best way to do it. But this is I think that probably is the best way most times to do it. But the pagination option is kind of intriguing to me. Again, particularly given that when you have a vector that's like this static set of things, it won't be growing and shrinking from the simulation versus submission. It'll be static. A lot of times it won't be a vector. Like in my case, I have that glyph, right? So I set it to whatever I think the max size would be, and then I just store that, and then slowly, instead of having everything be a 0, over time I fill up what that array is actually, the actual data of that array is, and then return or store that. But I'm always storing 1,000 values. I'm always reading and writing 1,000 values, but from the simulation, from the footprint. But what those values actually are is irrelevant. So that doesn't matter what the values actually are. That matters when it's the key, because that's something that actually gets included in the footprint. But what the value actually is irrelevant. The only thing that matters and cannot change is that the number of bytes you read or wrote between simulation cannot be more in actuality, can't be more in submission than it was in simulation, which is where you start to look at, okay, I'm going to need to store something that isn't variable, that doesn't grow and shrink. What the contents of those 100 items in the vector can change, but the fact that it's 100 items, that needs to not change. Hopefully, that made some sort of sense. Do we have any questions on that particular topic while I take a sip of coffee? Yes, modulo operation for that. You could also handle that. That's the way I've done a lot of my pagination. It's kind of the same thing as dividing, but modulo is a cheaper way to do it, or an easier way. I don't know if do modulos work in... Yeah, surely they do. Yeah, in Rust. Nothing fancy you have to do, like .mod or something. It would just round it. Yes, well, kind of. And remainders can work. It's just it would round it. So that's another thing to like be aware of, is if you're using modulos, like division and stuff in Soroban works great. It just won't return decimal points. And my goodness, will that come back to bite you if you don't understand how that works. It just basically floors it. So if you were to do a modulo, I don't know if this... there's like I'll get to a pro tip in a minute. This might actually tell me what this is if I did it as a const up here, because then it would be runtime or build time. Yeah, so it evaluates to 0 because the remainder of 10 divided by is, yep. So if we did something like 4, my guess is it would probably be the same, or 2. One cool thing you can do whenever you're dealing with, well, there's like 2 pieces maybe to this, is use the Rust playground, which you can also just write a test, which, well, maybe that's faster, but I use the Rust playground all of the time for trying to figure out like, wait, what's actually going to happen here when I run this code. Particularly given that we don't have float point math, to figure out what the value of something's going to be when I'm doing a big division, which is where Moots math comes in, and I can never remember fixed point. He really just another petition to rename fixed point math to Moots math. Moots, the guy who wrote it, I just call it Moots math, but he's decided to call it Soroban fixed point math, which is what it is, but it's Moots math. But essentially what this gives you is the ability to do divisions to a much higher level of precision without having to worry about, you can basically do U8 or U32, U64, I128 division without having to worry about the rounding stuff. It won't give you float point, but it'll basically, there's 2 ways to divide a small number, either have float point math or just multiply your numbers by large factors, and then you can, instead of doing 10 divided by 3, you can do 10 billion divided by 3 billion, and you don't have to worry about the decimal points. And that's essentially what Moots math allows you to do. So this is another one. When you're trying to do math in Soroban, this is going to be your saving grace. That, and yeah, you can also run tests, like if you're using Moots math, trying to figure out what a value actually is. You can write a test for it and try and see what those values are. It's pretty cool, and will help you not make mathematical mistakes by thinking. It's just so natural to think about, to like, oh yeah, decimal points. Who doesn't have those? Everyone who builds on Soroban doesn't have those. So it can cause a lot of pain and suffering if you're not thinking. Yep, sure. Actually, let me pull up. I do this in the Kale contract. So let me pull this up. There's a lot of things I don't have memorized about Soroban. And one of them is the things I need to write custom types. So when I'm writing, I've got a storage type, or a storage enum, I guess, that has a lot of different storage keys. And these are all like static keys. They'll have static values. And then you've got another one that's a static, or that's a value, but then takes an argument of some type. So in my case, when I call storage block, I pass it the index, and then it will get me the block at that index. And so I can have lots and lots of different blocks and not have to have stored them in a vector that could be growing unbounded. And maybe I say, well, after it gets to 10 blocks, I'll eject it or something, or 100 blocks, or maybe I'll use pagination and store 10 of them and then roll over to the next one. I can just store it, and then so long as I'm calling the index, I've just got a single item, a single key, which will give me a single value. And so that's what that item would look like. There's another one here for Pale. You don't have to pass a single argument. You can pass multiple. So like the one that I had mentioned with an address and a 32. This basically says there are lots of different users, and I don't want to store all those different users and their pails in a vector. So I'm going to store single values of those and just give an argument of some farmer key, which is the user, and then some index that they're getting stored against. So some value that will match against the block value. So basically the block is some universal item that will be the same for every single user, but then there's like your stake and your zeros and your gap values that I call as this pale item. That is going to be unique per user, and so I store both the user address as well as the block index. And so, isn't that sick? And you can store like custom values in there too. So like if you have your own, if I go and look at the passkey kit, I think this is the right one. We look at the contracts for this in the interface, which I think has all my types. You can write your own types, which are just like single struct items that then have some like custom item, and you can see these are pretty complex. And then when you go and you write some storage item, you can pass your own like signer keys. Like I'm storing the signatures, which is going to have a signer key, which is part of a map, which has an optional signature. You've got some pretty tremendous levels of flexibility here to kind of write whatever you want. And then when you go and store it, it's got all of that data baked in. So it's really just this choice between what should be part of the key and what should be part of the value, but both the key and the value can have, I mean, look at this one. I've got optional values in here as part of the key. A bytes n is part of the key. I actually don't think this is the key. Yeah, this is the value. The key does have some custom items in it though. But there's a tremendous amount of flexibility in writing pretty complex custom types, which will make your data far more expressive and not have to get in this place where we're storing things in a vector. Like you think of storage, that is your vector. It's a key value database. So just think about what kind of keys you want to store there. But yeah, both of the Kale contract, which is much easier to understand. That's hello world. Where is it? This Kale contract's pretty, I mean, it's not complex, but it does show some pretty neat capabilities between, I've got like this contract that has two traits. So there's like almost two contracts inside of one contract, where I've got one that's just like all of my admin functionality, and then another one that's like the farm, the contract, typical user contract functionality. And so I can then separate my contract implementation and say, yes, I'm going to build a contract, but I want to deal with these two things completely separately. So my like mental context is I'm going to deal with just the farm traits, which all come from here. So I know I'm going to be writing a plant function, a work function, and a harvest function inside of my contract farm. And so those are those three functions that I'll write here. And then my homestead, which is more like the admin functionality, can be dealt with completely separately. And then when I go to deploy it, it all deploys as one single contract, but like bundling all these things together. So it keeps it like logically pretty tidy. Yeah, so that's a pretty good place to go for like just some inspiration on how to do more basic storage. And then I think, yeah, definitely highlights some good pieces for like there's a couple others in here which are maybe slightly unrelated. Like if people have questions more about storage, we can talk about those. But another one that this one deals in is a lot of times when we're customizing values or modifying things, you really, really need to try and stay away from using env as much as you possibly can. Because anytime you're using env, you're calling from the guest environment to the host environment. And things that you do on the host are going to be very expensive. Things you do in the guest are going to be essentially free. And so, for instance, I've got a farmer coming in, which is an address. This is where I generate the hash. So I'm checking the hash that you sent me whenever you're doing a work method. I pull that in. I've also got entropy and nonces and indexes, but I've like very specifically made choices to not put this in like an actual bytes array, right? I could do bytes and then start modifying that, but because that would be a host item, anytime I went to go modify it by like inserting a new nonce or entropy or something like that, particularly if this was like happening in some sort of loop, that would get crazy expensive by calling the environment, by calling the host over and over and over again. So anywhere you can set static arrays, even if it's like, okay, I don't think I'm actually going to use 76. I'm going to set it to 1,000 because I don't actually know. I know it's not going to be higher than that. That's still going to be way, way cheaper than setting like a bytes n or something like that that uses the environment because host stuff is just expensive. So anywhere you can, use the actual raw bytes of things, which is one of the reasons I'm converting. Well, that's actually not why I'm converting to XDR here, but I do need to be able to take an address and convert it into bytes so that I can add it to the actual hash that's generated. But that's a little bit different or tangential to the conversation. But ultimately, I have learned through pain and suffering, just don't use the env if you don't have to. Now, obviously, I'm not going to be doing CAC math, hashing outside of the environment, but the less I can use it, again, when in doubt, just grep env and look at all the places that you're using it and then try and reduce it, particularly when you're creating data or modifying data or looping over something that touches env. So it's great to do loops, just don't loop over env when data is involved. Yeah, that's actually a good point. Tupoi, I don't know what your name is. I'm going to call you Jeff. I think to generate like a linter that can look and see like when we've made Phil. All right, that's better. I'll call you Phil. When you're calling these values and making contracts, it would be nice if there was like a, hey, just so you know, what you're doing here is stupid. I think TDEP also was looking at doing something like this. And I'm hopeful as the ecosystem matures, maybe we can get some players from the Ethereum ecosystem that have written linters like that for Solidity to start looking at stuff like that. Ultimately, I think you could probably do some profiling off of contracts as they run and just leave yourself an upgrade function and then look at profiling to see, what's being expensive. Oh, there's all these byte creates. And then you could retroactively go back in or potentially do like a fuzz test that keeps track of how expensive things were. That could give you some idea of optimizations or areas for optimizations. It is a little tricky to like know what's good or what's bad. Looping over an env may be your only option, and I guess you could ignore it. But a lot of it does boil down to, just because you know something's not the wisest doesn't mean you necessarily know what the solution would be. Like if you're looping over addresses, what are you supposed to do? Like not, I guess, loop over a bunch of bytes arrays that you've converted your addresses and now your syntax starts to look a little funky. But that's not always a bad thing. Again, if you're trying to optimize for costs, sometimes you have to do pretty funky things. But I would hope that over time we'll get some linters that'll at least, make some suggestions or that could run a fuzz test over your contract and find areas where things are very expensive or more expensive than you might expect. It's another area that I think AI would be pretty interesting, where you give it the whole blockchain and all of the invocations that are happening, and it runs like a cost profiler on all of those things. And then finds out like what's normal, what's happening in the ecosystem, and then can kind of measure your contract's performance against the entire blockchain's performance and give you some idea of what's normal or what's out of scope or what's more expensive than what most people are doing. It's ultimately a little bit hard to know what's normal or not when you don't have more context than just the code. There's certainly some things you can know, but again, depending on your contract and its logic and your requirements, a linter can only take you so far, and I think in some sense could be a little bit dangerous where you end up being like suggested things that are actually non-optimal or may introduce other areas or other issues, right? A linter may say, hey, this is a really bad idea. You should break this contract up into a bunch of cross-contract calls. And you're like, okay, I'll change everything into cross-contract calls, not realizing that contract invocations, like spinning up a cross-contract call, is 10 times more expensive than looping over a host environment. And now you've just made your contract even worse by fixing a problem that you didn't actually understand. You were just relying on a linter to tell you what to do. Again, I don't think it's a bad idea. It's just definitely not a magic silver bullet. Just reading back through some of these things. Yeah, I'm interested in Zig. Isn't Bun? So I think Deno is a Rust, compiled to Rust, and then Bun is written in Zig. Fascinated by Zig. But I don't know. I don't think there's any work necessarily being done right now on making an SDK for people to write contracts in Zig. I think somebody has. I know TDEP has deployed a contract at some point off of a Zig contract. But yeah, you kind of have to essentially rewrite the Soroban SDK in Zig, which is no small feat. But it would be cool. All right. Any more questions or concerns? Otherwise, we'll wrap up here. I'll get back to work on trying to get a Kale miner in the browser, and you guys can go convert all your contracts to not use unbounded vectors in values. All right. Fantastic. Appreciate you guys as always. Have a fantastic week. Go mine yourself some Kale, some FCM, the granddaddy of all smart assets, proof of work assets. It's a good day to be building on Soroban. We'll catch you all in the next one.